Okay, so let's review Unit 9 one more time, even though you just had a test on it. This is important stuff. So, can you identify whether it is a relation or a function? Remember, a relation, you will have x's that repeat, and if it's a function, no x's repeat. Okay? And it also passes the vertical line test. So in an example like this, the first thing I notice right off the bat is I have two x's that are the same. It is absolutely not a function. For the domain, I'm going to put them in numerical order. So I have -1, I have a 5, and I have a 6. In fact, I have two 6's, but I'm not going to write both of them. For the range, I'm going to go in numerical order. I have a 4, I have a 5, and I have an 8. I have two of them, but I'm not going to write both. Then the domain, all of this domain and range, this is your domain, this is your range. -1 and 5 and 6. I'm just transferring this information to here. 4, 5, 8. I'm just transferring that information to there. And then I'm going to go match. 6 goes with 8. -1 goes with 5. 6 also goes with 4. And 5 goes with 8. Okay. So when you see an x value that has two lines coming away from it, it is not a function. Okay. For a graph, if is a function or not, if you just look at your vertical lines that are made up of your graph paper, you can see that they only touch this graphed image one time. So yes, because this passes the vertical line test. Okay. This one here, same thing, all of these vertical lines. Okay. They only touch that graph once each. So yes, but then here, all of these vertical lines, they touch the top and bottom of the circle. So this one is not a function. But we do need to come up with our domain and range. So first of all, when you see arrows, we're talking about infinity. If I were to take this curve and flatten it out from left to right, it would go this way and this way. That is negative infinity and positive infinity, and those are my x's. Okay, so negative infinity is less than x, which is less than positive infinity. Every x value is bigger than negative infinity, but smaller than positive infinity. Now, if I took this same graph and I stretched it vertically in both directions forever, it's going up toward positive infinity and down towards negative infinity. So same thing for my range. Okay, every y value is bigger than negative infinity, but less than positive infinity. Okay, for this graph right here, it's coming up from negative infinity. It gets right here and then it goes back down. Okay, so think of like when you bounce a ball toward the ceiling and then it goes back down. It can't go higher than the ceiling. So what number is the ceiling? Okay, so this is a 0. And we're going down towards a negative infinity. Okay, however, I guess I could make these a little more. There we go. Now you can see them. However, from side to side, these arrows right here, if I were to flatten this out side to side, instead of like a rooftop, I'm going from negative infinity all the way to positive infinity. So my x's are negative infinity is less than x, which is less than positive infinity. So it's every x value left and right. The y values, they're coming from negative infinity. They're going up to 0. This is a 0. And then they're going back down toward negative infinity. So negative infinity is less than y, which is less than or equal to 0. Okay. Another thing you can think of, well, I'll go over that in a second. As far as this particular picture is concerned, the top of the circle and the bottom of the circle is your range. Your maximum y value is going to be a 3, and your minimum y value is also a negative 3. And then we're going to look from side to side. So we have these two. Your minimum x is 1, 2, is also negative 3. And your maximum x is positive 3. That just happens to be a coincidence. So your domain, your left and right, negative 3 is less than or equal to x, which is less than or equal to 3. It can be negative 3 and it can be positive 3 and everything in between. For the range, it can be negative 3 and everything in between that and positive 3. Okay? So something I want you to keep in mind when we're talking about domain and range is, okay, your minimum x value, and then you're going to need your sign, and then the x, you got to write that letter, and then you need your sign again, and then you want your maximum x value. Okay. Same thing for your y's. Okay, minimum y number in whatever sign, and then the big Y value there, or Y letter, okay, and then your sign, and then this would be your maximum Y number. Okay, so just think of minimum and maximums. Graphs get domain and ranges like this unless it is just a graph of dots. But domains like this, or a table, or something like this, anything that looks like this, or even a table of values, those are going to get these kind of domain and ranges, okay? All right, so let's do a little bit more. Okay, let's go ahead. This is page 10. I'll just do the top here. All right, so degree and type. All right, so you have a degree of 0. So that type is called constant. When your degree is a 1, that is linear. When your degree is 2, that is quadratic. And when your degree is a 3, that is called cubic. So the number is the degree, and the word that goes with it is the type. Okay? Now linear, that's this, right? Y equals mx plus b, right? Y equals mx plus b. That's what this looks like. So it's a degree of 1, and we call it a linear function. This one here, you see how we have an x here and an x here? That's where we're going to get these x squareds. So ax squared plus by is equal to c. We're going to get something like that for a graph like this, and we're going to learn this more in the future. But this x squared, okay, because we kind of have this going on. Here I just have 1x, right? But here I have 2. So this is a degree of 2, and it is quadratic. This one here, this is y is equal to negative 2. There is no x in there at all. So it's a 0 degree, and it's a constant because every y value is constantly negative 2. And then finally, we have this here. See how it's kind of like, it's got like this little section, and then this little section, and then this little section, right? You can kind of think of it like 3 little sections. And there's a lot more to it. I'm just trying to give you something to latch on thinking wise. So this is a degree of 3, and this is cubic. Okay. All right. So this is a graph where the equation would have an x cubed in it. Here I don't have an x, so right, there's nothing there. This would be like -2 times 1. So here's x to the first, here's x squared, x to the 0 power, and here's x cubed. And that's what these are referring to. Linear, quadratic, constant, and cubic. Okay, so I'm going to stop here. I'm going to post another video. For the next, we'll do piecewise.